Hi, I'm Audra. Like I shared in part 1, I'm a quantitative researcher, not a statistician nor a mathematician. I say this to emphasize that what we're talking about doesn't require anyone to like or to necessarily even be good at math. It does require some good reasoning skills. Of course, I've taken a lot of statistics classes, but what my original stats professor shared with us, that it's about reasoning and understanding what you're doing, made it a lot easier to overcome the mental block to analyzing data. That's probably what a lot of you face. However, as we continue in our journey to demystify the practicalities of actually having to run and interpret statistics, the second of 7 podcasts is about translating the questions you asked into testable variables. We seldom analyze data just from raw questions. Sometimes we will. However, SPSS makes it easy to know how to group and analyze our variables. There are 2 assumptions that we have to make before we move forward. First, that you're already familiar with your research methods. This podcast series isn't about teaching you what research methods are and how to approach research. You should already know that before you start watching these. Second, you have a data set that you're trying to work with. The series is designed so that you watch some podcast material and then try it yourself, pausing as you go along. So let's move into the second installment in our series, factor analysis. In this podcast, we're going to start assuming that you've already cleaned up your data, you've renamed variables, changed labels, sorted out your values, missing values, and recoded any questions you needed. If you're not sure how to do any of this, go back to podcast 1, familiarizing yourself with your data file. Now, in most social science research, we rely on using scales, asking several questions to get at the same concept. In your literature review, and when you were putting together your questionnaire, you probably used this scale and that scale for your variables, but you may not have known how those several questions would get analyzed together. This is the starting point. We also have to make sure that these scales are reliable, that respondents are actually responding to them in the same ways. So no matter if you have scales that you've borrowed from other people, or if you've written your own scales, this is where we start. From a practical standpoint, you also need to be able to condense 3 to 15 questions into a single answer for your analyses. Factor analysis is a multi-step. Alright, so for our demonstration, let's start with our questions. I'm going to show you how to run factor analysis with 2 types of scales. Those we have already that are established, as well as new ones. So here are our questions. We were asking respondents about their attitudes towards flying and airlines, and we're trying to figure out how much the respondents knew about a particular airline and how they felt about flying in general. The perceived knowledge of an airline is an established 4-item scale that has previous really high reliabilities. However, to demonstrate that our research is reliable, we should run the factor analysis again. The second set of questions are new ones. We weren't sure how people's perceptions of flying would group together, so we're exploring the factors that affect how people feel about flying, ranging from their domestic versus international anxiety, beliefs that it affects them personally, and particular worries. So this would be called an exploratory factor analysis. So let's open our data files. Notice that I am now going to be in our recoded data file. This is the one I'm actually going to use when it comes to analyzing my data. So from here out, we're not really going to be doing much with our data file until the very end. So we can go ahead and minimize that and work completely out of our output file. So now let's save our output file. I like to keep separate output files for each group of analyses. So let's save this as our factor analysis file. So you can pick where you want to save it. I want to save it with our research methods and our data files. And so we say factor analysis. So make sure that you have saved your output file, Analyzing our factors is a three-part process. In the first part, we run the factor analysis. In the second part, we run a test called Cronbeck's alpha to identify the likelihood that our questions actually measure the same concept. Then in the third step, we compute the variable to combine all the questions into one so that we can run our analysis. So let's start with step 1, running the factor analysis. To begin, we go up here to the Analyze menu. Then we scroll down here to select the dimension reduction and then the factor menu. Now you see this pop-up box. Let's enlarge it like we did in the other video. Now, because you've already cleaned up your data and labeled everything, it shouldn't be hard to find the questions that you wanted. A quick pro tip, you can change the size of the box so that it's easier to read and you have a longer list of variables instead of trying to just expand them. So, let's go through and let's find our pretest perception of knowledge. Now, just like we did in the other podcast, we can select all of them, move them over. So we're doing it starting with the pretest perceived knowledge ones. Now what do? You need to know which of these boxes actually matter. In SPSS, they give you a lot of options to tick. Your best option is not to tick anything more than you need. So don't change anything in the descriptives menu. Just ignore it. Then we go to the extraction menu. You click on that. And what we can see here is this unrotated factor solution. Let's take that out because it'll just confuse and it adds more information to your output file and you don't really need it. Leave everything else as it is and click continue. Now we go to our rotation menu, and what we want to select is the Verimax option. And you want to make sure that this display rotated solution option is checked, and then we hit continue. Change nothing else. So, you don't need to look at the scores or the options. We're all set, and we just click OK. So, let's take a look at our output. Remember, save early, save often, save your output. So, keep in mind that perceived knowledge is a previously tested factor, so we would have expected all 4 of the questions to come up together, and they did. So this one's really easy to interpret. You can ignore this commonalities box. It doesn't tell you anything that you need to know at this point. SPSS printouts tend to give you a lot of information that you just don't need. So in these podcasts, I'll let you know what to ignore and what to pay attention to. We're also going to ignore this component box. As a matter of fact, you can just delete it and get it out of the list altogether. So if we look at our output for perceived knowledge, in the rotated component matrix, we see this note that only one component was extracted, so the solution can't be rotated. What this means is that all 4 of our questions hang together as a variable, as perceived knowledge. When we look at the total variance explained by our component, what we want to see are 2 numbers. First is this total of 2.89, and this gives us our eigenvalue. This you'll need to keep in reporting your write-up. The eigenvalue is an important number to be reported because it tells the strength of the component itself. The general rule of thumb in data analysis is that any value over 1 is considered to be a viable component. Obviously, the higher the number, the better. The second number that you'll need to report is the percent of variance, because factor analysis is looking at whether respondents typically answered all the questions in the same way. That is, they gave a 2-to-1 question. If they gave a 2-to-1 question, they're likely to give a 2 to all the questions. So let's look at how much variance in people's answers was accounted for by the components extracted. So in this case, ours is 72.31%, also pretty good. So this tells us that perceived knowledge is a clear component. However, that's just the first step. Now in step 2, we take these same 4 questions that were identified as all part of the same component in step 1, perceived knowledge, and we establish how reliable our measure is. To do this, we go back up to analyze, we come down to scale, and we click on reliability analysis. So we go in and we find our questions again. And we click them over. You'll find that all the tests in SPSS in these pop-up boxes start the same way. Find your questions from the list on the left, take them from that, put them in the right box. Here, click on Statistics, and here we're only going to select Scale if item deleted, and click Continue. Now, click OK, and our test runs. So, what we have in this box are 3 information boxes. The first one you could ignore, it's just the descriptive statistics. The second one, however, gives us our Cronbach's alpha. So for ours, perceived knowledge is 0.87, which gets rounded, the 0.868 gets rounded to 0.87 because when you're reporting statistics, everything is rounded to 2 decimal places only. Now, how to interpret this? Anything over a 0.7 for Cronbach's alpha is considered very good. So we know that we have a reliable measure of perceived knowledge. However, the third box also gives us some important information. Let's say that our alpha score was lower than we would have wanted. It was below a 0.7. We can look at this third box to see if the alpha would improve if we took one of our questions out. So an excellent scale is one that if you take the question out, the alpha would actually go down or stay roughly the same. So if you look at the far right column under Item Total Statistics, you can see that we have an excellent scale. The alpha would actually go down if we took out any of the first 3 questions, and to be quite honest, it would be about the same if we took out the 4th question. So we can say now with confidence that perceived knowledge is a reliable measure. So let's save this. So now what we need to do is to calculate a new variable that combines all 4 of these questions into one so that we can run our statistics, because we just do not run our tests on the individual questions. That's why we want to do the factor analysis. That's why you have these different scales that you've probably found in your literature review. So now we go to step 3, computing the new variable. Computing a new variable in SPSS is typically done in this circumstance, when you're trying to take several questions and combine them into a single test variable. In this case, perceived knowledge of the airline. So we begin by taking a look at our transform menu, then we click on the top option, compute variable. So now let's start on the left. When we want to enter in our target variable, type, and label. So on the target variable name, this is the name like in your variable view, so you want to enter the short version of the name that you would see in the first column of your variable view or in the columns in your data view. So I'll call this perceive no. Now, then click on type and label. The numeric should be the automatic one checked. Leave it as it is. Then type in your label. I'll put in perceived knowledge airline. So then you just click continue, and you need to click on select the function group on the right. Click all in the box, and then you see this group of things pop up below, the group of the list. So you want to scroll down the menu until you see mean. Click that, and then this arrow in the center, click it up. And that tells us that we have in our numeric expression, we have the start of the functions. So take out these question marks. You can group and highlight them or just delete them one at a time. And what you want to do then is to select your variables from this list below. Again, our same variables, we can expand it out. And so we come down to our pretest knowledge. Highlight, and you have to do this one at a time. You can't select multiple. So you highlight it, and you click the arrow over. Now, because you're basically programming what it's supposed to do, the syntax matters quite a bit. So you click this over, you put a comma, and then a space. Then you go to your next one down the list, you highlight it, and you follow the same procedure. You did this for each of the variables that you're trying to compute into your new variable. So when you come to the last of them, what you want to end up with is the last of your variable labels and no spaces and the right parens. So at this point, see that this OK is there? If it's not highlighted, if you can't click on it, you've done something wrong in your syntax. But ours says OK, so click it, and we now have a new variable. So if we pull back up our data, and we go into our variable view and scroll all the way to the bottom, we will see our new variable, perceived knowledge. Now, my recommendation is to move the computed variable up towards the top of your variable list. When you start running your tests, this makes it much faster and much easier than scrolling through the list of all of your questions to eventually get to the test variable. In order to do that, just click on the number that you've highlighted and just move it on up. If you have a long list of variables, it can take a little while. But this is the advantage in it because, as you saw with all of those variables that you might have, if you have a long questionnaire, this makes it a lot easier when you start to do your analyses, so you don't have to scroll through lists and lists and lists to get to the ones that you really think matter and that you're really going to be testing based on your research questions or your hypotheses. So I want to put it right about here. There it is. And what do? Save early, save often. You've computed it, it's there, and you don't need to change anything else about it. So that was an easy factor analysis because it used an established scale. Let's run the factor analysis now for one that we don't necessarily know what the factors will be. People's attitudes towards flying. Now, steps 2 and 3 would be exactly the same for each factor that we identify, so we won't rerun those steps. So let's go through a quick refresher on the process. We minimize our data, and then we go into Analyze, down to Dimension Reduction, over to Factor Analysis, and what you see is that it's still populated with what we had done already. Now, one nice thing about working in SPSS, after you've clicked all the boxes and you're still in your same section, that is, you haven't closed out the program, it remembers everything that you clicked the way you clicked it. So we get rid of our perceived knowledge questions by moving them back over, and then we're looking for the attitudes themselves. So we look at the questions, and they start with I'm completely comfortable flying domestically, down to I often worry. So we just have to find those in our list. And here they are. So I am completely comfortable flying domestically. We select these all the way down to the government. There. And we click them over. Remember, because SPSS saved what we were doing, we don't need to do anything else. And we click OK. Again, we ignore this first box. Now, in this case, we have 2 components that are over 1. So we know that there have been two variables that have emerged. So we keep track of our eigenvalues and our percent of variance. And we take a look at the cumulative, and it's taking care of a good chunk of our percentage of variance explained. So we look down at the particulars. When we look to our rotated component matrix, we see these two components. So what do we do with this now? How do we know what variables are grouped together? First, you go column by column. So in this first column, you can rule out any variables that have a negative sign. Second, the basic rule of thumb is a 0.60 split. So if you look at the component loading number, which is listed right here, we want any positive number that is over 0.60. So we can see the following are the questions that group together at the above a 0.60. I often worry about airline safety. I believe that airline safety is something that affects me more than most. I often worry that people who fly will carry diseases to other places. I often worry that airlines are not doing enough to protect their passengers, and I often worry that government is not doing enough to protect passengers. Now, before you go to the Cronbach's alpha test for this first factor, do a logic test. Do these questions make sense together? In this case, yeah, they do. They're all asking about different levels of personal anxiety over flying. So assuming that the Cronbach's alpha test is over 0.7, remember back to our step 2, then we have a variable that we could call personal flying anxiety. And then we would follow steps 2 and 3 for this one. But here we also have a second variable to think about, the second component, which seems to be a flying confidence variable. Now this seems to be the exact opposite of the other one, so it would be worth checking out to see if you'd already reversed coded it and rerunning the factor analysis. However, what often happens in attitudinal research is that confidence or efficacy is quite different from worry. So assuming that you had already reverse coded the data, which this was, then you would have a separate variable that you could call flying confidence. Now, most of the time, it's best if you have 3-item or more variables. However, you can use 2-item variables as well. So to check this one out, we would follow steps 2 and 3 as well with the Cronbach's alpha and then computing the variable. So from just these questions, we have potentially 2 good variables. But you'll also note that there's one question that didn't work with either of the factors. This happens, that's all right. Not all of the questions that we ask will group with the others. So you have a choice. You can either ignore them in your analysis, or if you think that they're important, you can treat them as a single item factor, which means that you don't need to go through steps 2 or 3, you just report them in your methods as the single item factor. Once you've done your data analysis and your factor analysis for all of your scales that you've included in your survey, and you've gone through all 3 steps for each of them and identified any single item factors, you'll need to summarize all of this for your method section. It's always important in statistics to show your work. So here's a table template that you can use for reporting all of your factors together. What this does is it shows all of your relationships. In this case, it's these relationships, but think about it as just your key concepts that you have discussed in your literature review, the variables themselves that you have analyzed, and the particular questions that make up each of these variables. Then, in your other 3 columns, you have the numbers that we saw in our component matrix. So, we have the eigenvalue, which is this number again, and that's reported right there. We have our percent of variance, which would be reported in this column, and then we have our factor loadings. These are our factor loadings, of course, rounded to just 2. Now you can see here, age and gender are obviously single item factors, so you put the not applicable. For all the others, you put in the values as they go. Now, if you do this as you go along, if you start working on your tables as you move through the data analysis, you'll find that writing the paper is a lot easier. And at the end, you don't have to spend hours and hours putting all the data into tables. So if you do it as you go, keep your results in a Word document with your tables, key results, discussion points. Then, as you begin to write the paper, it's a lot easier to write both the methods and the results and discussion sections of your papers. So you can copy and paste the tables into your methods and results as you write, and you can take a look at the key points and incorporate those into the discussion and/or the conclusions. So that's all for podcast 2. You should now try to go through your own factor analysis while it's still fresh in your mind. In the next podcast, we'll talk about good decision making, how to get ready to run your tests in an organized, purposeful, and time-efficient manner.